tomorrow can be seen in today's achievements and can be forecasted based on them. However, the day after tomorrow is not that well predictable. The next report will give an attempt to forecast the AI the day after tomorrow. And to do that, we need to go from individual AI systems to researching large ecosystems and social systems in heterogeneous networks of AI in this multipolar, unpredictable world. What is needed for the effective work of such systems? Alexander Gorbain, the author of 20 books and 250 scientific papers, is going to talk about that. He's also the winner of the official title Pioneer of the Russian Neural Informatics. More than 30 students of Professor Gorbain have a scientific the PhD or the Doctor of Sciences degree. Doctor of Sciences degree is 7. Doctor of Physical Mathematical Sciences, the leading fellow of AIJ, the professor of Central University, Alexander Gorbain, multi-agent intelligence, 10 billion people and 10 trillion AI agents, a hallucination about the future. Hi everyone, it's my great pleasure to see you all. I'd like to describe you the title of the presentation. Why hallucinations? I will try to change my usual role and to talk about the prediction, the forecast for the development of the scientific and practical field. Hallucination has become a buzzword in AI, but basically what it means is the error in disguised as something in the plausible clothes. People like to come up with some new terms, and hallucination is one of them. It's my second time when I give a presentation about AI, predictions about AI. The discussion about neurocomputers was my first presentation. In 1998, everything was fantastic. We had deep learning, but we didn't have two important things. First of all, I couldn't predict what would happen when people will have internet. There will be one system that would capture and recycle a huge volume of text. Of the internet, that was, a pretty vague thing back then. But it happened in 2000s. The second thing is that the community didn't do me a favor. When I looked at what can develop fast AI and neural network AI, I said there is a task where we can use the mythological principle. The task of managing fusion reaction in real time. And when the cybernetic management and control of the thermal nuclear reaction, when we understand how to do it, we could do that. We could do that, but people are afraid to do that. Thermal fusion is something that people don't know anything about, and they think that the failure rate will be pretty high. So I had two forecasts back then. Now, my idea is as follows. The forecast is always a hallucination in a way, so I stand to be corrected. But it's based on my work, on the work of other scientists, and well, based on the experience and based on the fantasy as well, of course. Now, they have already flown out and they will arrive soon. That's about the multi-agent systems. That's how it looks like in our fantasy world. Now, the first section of the presentation is going to talk about popular predictions of AI development. Second, Agent AI, top strategic technology trend for the next 5 years. So priorities change. The generative AI is leaving the scene in a way. The topology of division of labor between agents is a very important thing to talk about, and the epilogue. Now, a popular prediction about AI. Unfortunately, there is nothing here, but that's a well-known Gartner cycle that should be put in the textbooks for high school kids. We are living in the century of innovations. How do innovations work? First, there's this trigger, then it's going to a hype. You have to believe in the hype, but you have to be cautious, because then it will go into an abyss of broken illusions, of disillusionment, and then some of the solutions go to the productivity plateau. Gartner also made the assessment of the productivity. Now, 2023, what is the hype? What is the most hyped up technology? Well, ChatGPT, generative AI, foundation models, all of this stuff. Everything that you saw everywhere that generates nice pictures. 2024, it fell down from that hype into the huge and black abyss. Now, engineering AI applications are coming out. Generative AI is on the bottom of the abyss, but Gartner is they gather experts from around the world, and they predict the following: that in 5 years it is expected for the Gen AI to go to the productivity plateau with a high level of certainty. Multi-agents, that's more exciting. Multi-agency was discovered a long time ago, but it's still at the initial stage of innovations, forgotten somewhere in the warehouses. I removed this small square at the start, and at the end, the multi-agent systems. Yeah, here it is, by the way. Yeah, right, there at the bottom part. They're still at this warehouses, so to speak, although they were tested quite a long time ago and discovered a long time ago, but I think they have a great potential. In 2024, in October, unexpectedly, Gartner organized a conference. That was October 2024, just a couple of months ago, and said that a strategic priority, a strategic main top priority for the next 5 years is agent-based models. Agent AI. I've heard a couple of reports today about Agent AI, so I'm going to repeat some of the ideas. Now, Agent AIs, what do? They assimilate large language models to be able to talk and communicate with people and to have some reasoning. Secondly, it works with the modern systems of data storage, extraction, and data collection, so on and so forth. Third, reasoning, planning, these things. Reasoning, planning, and model generation. LLM goes, and this Agent AI goes in the real world. That's the major difference. And people who write about that write that this is the major difference. And then it learns and learns and learns within the cycle. And these agents that absorb LLMs and use it for reasoning and for communicating with people on the language that people understand, these agents are considered now to be the core technology of the future. Moreover, they say that on the long term, around 20% of all, no, what, 15? Yeah, Gartner predicts that by 2028, what, in 4 years, at least 15% of all day-to-day decisions will be made autonomously by agentic AI, up from 0% in 2024. But we can talk a lot about agentic AI, but now it's 0%. So it's tomorrow, and the tomorrow has already come, and the Gartner was really concerned that the tomorrow has already come, and they decided to reflect that in its forecast. But what will happen the day after tomorrow? I've discovered that people do not know who invented what. AI had great creators. Marvin Minsky, who in 1961 published a great works, The Steps Towards Artificial Intelligence. And basically, we are moving by these steps. You can check that out online. There is another important notion that Minsky introduced. It's called a micro-world of AI, or micro-world of an intelligent agent, something that should be taught in school. Because, you know, I say code is not... a cat is not living in the house, it's living... It has its roots. A person does not live in Moscow. A person lives in the small, idealized world. It's a kind of a sub-world, an idealization, idealized world. And AI agents, they live and work in their micro-worlds. A micro-world, as Minsky explained, is a model, a pretty simple one, that is put on the real world and is adapted to it, and within that world an artificial agent is working. It does not see any other reality. The reality is something that it can see. And he says that an agent with its micro-world. And as for the reality, to understand the reality, you need a lot of agents. Multi-agents within the systems is something that poses this cross-cultural situation. Communication, there's a communication problem. Agents do not understand each other. You have to train them so that they can communicate with each other. And there is a orchestration problem. Configuration might be another word. So orchestration of the agent communication and interaction. Every agent works within their own world, and they're built around a real world. And when you can combine them and configure them around this world, you can get something more or less realistic. This is the task. But the agents do not die. That's the most important thing. So we can always hope that in some point of time they will be smarter and smarter and grow. Right, so what is the interaction between the agents that we might see? Obviously, it's... I mean, every time when you talk about the agents, you have to think about the division of labor. This is a cooperation that we had with an orchestrator that controlled that. We might not have an orchestrator. Coalition and teams. Coalitions and teams, within them agents exchange information and remove each other's errors and train each other. There are methods, there are small agents that are correctors. It trains within the system. And you can, have this corrector that will just correct these mistakes, so as to not change the overall structure of the system. How does it work? That's a working system, by the way. That's how it works. Yeah. That's the first is coalition and teams. The rules of interaction is cooperation, sometimes competition, by the way. Sometimes we have conflicts there. But yes, otherwise it's mutual cooperation, correction, and mutual learning. Algorithmic systems. I have two examples here. You know one very well. You see it every day, although not in such a in such a way. You see yourself in the mirror every day. You see computer every day. But as for the intellectual and smart agents, I didn't want to draw that because I thought about this thing. So I took a book that was published in 1999 that really talked about all functional components for the simplest AI components. It's called deep learning right now. So what is deep learning? Something that was called conductionism in 90s and 80s. There's no other deep learning exists in. So these convectionist systems, the neural computer, the project of a standard, this author, Mirkas, analyzed the standard components that could be agents in a system, that could act as an agents in the system.
Next, we move to the hierarchy and mixed structures. And here we come to a mythological image, same as ChatGPT amazed everyone. This is not AGI, this is not human intelligence. This is something, some entity that usurped all of the texts on the internet. It's an assimilator. And now, once we have assimilated all agents, and what is an agent? An agent is this multi-dimensional world, realm, a multi-dimensional language, if you will. So this brings us to the metaphor of the global serpent. This is a good excuse for me to reference my own publication. By the way, the ideas expressed there were simultaneously expressed in the publication by Jacobs, Jordan, Nolan, Hinton, again, Gilev, Gorban, and Mirkas, published at pretty much the same time, by the way. The epilogue is the bright day after tomorrow. Humankind will create enormous libraries of data and agents. Agents will not be dying out, they will be accumulating. All of the successes of large models will be inherited by agents, except they will be magnified. We will have these huge libraries of agents, and same as large language models, they will be superpower agents. But large multi-agent systems will be active in and of themselves, and they will be working under the supervision of large systems. The number of agents will be increasing because they do not die. And people can just relax and enjoy. I don't know what exactly will happen, but that's how I see it. And then there is this great chapter of challenges started by Gilbert. In 2019, 3 academies of engineering gathered together in London at a huge summit to discuss the main engineering challenges in an unpredictable world. They started with 2 challenges, no other. Will technological advancements change humanity for the better? And if they do, then how? You remember the Soviet cartoon about Winnie the Pooh? And the second question is, can we provide food to 10 billion people in 2050? You can find this online, highly recommend. There are 12 main challenges in total, and that's my presentation. Thank you. Alexander Gorban, thank you very much for these hallucinations about the future. Loads and loads of questions for you. How should the system of education change to prepare people for living and working with a multi-agent AI? An excellent question. The frank answer is, I don't know. Another answer is you need to train kids based on specific problems and tasks. The lecture that I just gave, the presentation that I just gave, is useless. You need to teach based on practical tasks in a friendly context with multi-agent systems. That's how you do it. Being adaptable, working on practical tasks, multicultural contexts. That's, I think, the recipe for success. Thank you very much, Alexander Gorban. A round of applause. Doctor of Physical and Mathematical Sciences, Professor of Central University, Alexander Gorban.